Hello students. So today we will see realization of digital filters using different methods of realization such as direct forum 1, direct forum 2, cascade forum and parallel forum realization. First we will discuss direct forum 1 realization. Okay. So as I said before, right? So we need some elements to design the um digital filters such as adders, right? Multipliers, constant multipliers, unit delay element, and unit advanced elements, right? So how we are representing? So as a diagram, so the adders we are representing like this, right? So this one is the input, right? So this one is the output. So we have two inputs, right? X1, X2. Okay, then output is X1 plus X2, right? So similarly, so the constant multipliers, how we are representing as a symbolically, the multipliers are representing like this, okay, as it looks like a arrow, okay. So x of n is multiplied with a, the output is a into x of n, okay. So similarly, that delay elements. So if we are representing delay element, so using Z inverse. Okay, Z inverse x of n, Z inverse. The output is y of n, right? So y of n is equal to x of n minus 1. Correct? So, for example, if it is the delay element is 2 means how we are representing x of n minus 2. If it is 3 means we are representing as a x of n minus 3. So, similarly, we can also represent as the time as an advanced element also. So, instead of putting inverse, just we have to use Z, that's all, right? Z input x of n, then output is x of n plus 1. This is a representation of advanced time element. Okay, x of n plus 1. For example, if it is z square means x of n plus 2. So these are the basic elements we are using to represent the digital filter. Okay, ma'am? So this is the difference equation y of n, right? So as I said before, this one is a m is a number of zeros. So n is the number of poles that vary from k is equal to 1 to n. The number of poles is varies from k is equal to 1 to n, right? Similarly, the zeros, right? M is represent the number of zeros that varies from 0 to m. So these are the AK and BK are the coefficients. AK is the coefficient of y of n minus k. Similarly, BK is the coefficient of x of n minus k, right? So, so after substituting the value of n and m, so we will get one equation, right? So this is the equation, final equations. Here we are splitting this equation in the two format. So we are segregating the equations. So the a variable a as a separate equation and variable b as a separate equations. See here. So this b coefficient is multiplied with the input signal, right? X of n. So these are the one set of equations we have to represent as a omega n, right? So similarly, this is the another set of equation. A coefficient equation is a another set of equation. Again, we are representing that one as a um, that one is also a omega n. Okay, so we will see how to draw that structure. Okay, so first we will take this b naught coefficient equation. Okay, so see here. So x of n is the input signal. This input signal is multiplied with b naught, right? So here b naught is the constant multiplier, right? So here we are by using this arrow we are representing the constant multiplier b naught, right? So here the x of n is multiplied with b naught. So this arrow represent, right, x of n into b naught, right? So for this term is added with b1 is multiplied with x of n minus 1. How we are representing this x of n minus 1? Using a delay element, we can possible to represent this x of n minus 1. Where is that delay element? This is the delay element, right? So it shows the x of n multiplied with z minus 1, right? I mean x of z into z minus 1, x of z minus 1, right? So this box represent the delay element x of n minus 1. This one is multiplied with the constant coefficient b1, right? So x of n minus 1 is multiplied with is multiplied with b1 coefficient. This is the second term of the equation, right? Similarly, the equations goes, right? If it is the delay element is x of n minus 2 is, I have to add one more element, right? So it becomes, this is z inverse. It shows n minus 1, first delay element. This is the second element, delay element. So the delay element, how we can represent x of n minus 2, right? So x of n minus 2. So it is a one delay element. This is the second delay element. If we are combining these two elements, it becomes x of n minus 2, because these two delay elements is multiplied with x of n, right? So it becomes x of n minus 2. With this x of n minus 2 function is multiplied with the constant multiplier b2, right? The first x of n is added. This is a adder symbol, right? So first term is b naught is multiplied with x of n plus b1 is multiplied with x of n minus 1 plus b2 is multiplied with x of n minus 2 plus and so on. So we are getting this equation. So the output is omega n, right? So we have another second part of the equation, that a coefficient equation, right? So we will see that structure. This is a direct form 1 structure. So before that we will see the how many multiplications and additions required for direct form 1 structure. Okay, so as I said before, so m is a number of zeros, n is the number of poles, right? So m plus n plus 1 is equal to, right, it gives the multiplication, total number of multiplication, right? So the number of multiplication and addition is entirely depend on number of poles and number of zeros in the given transfer function, right? So here the number of required multiplication is m plus n plus 1, right? The addition is m plus n, right? So we need memory location to store the multiplication, right? M plus the number of the total number of memory location required is m plus n plus 1. That's all. Okay. So now we will see the structure of that second term, right? So that a coefficient structure, direct form 1 structure, right? So here again omega n is the input, right? So this omega n is it is not multiplied with any constant, right? So y of n is equal to omega n, right? Y of n is equal to omega n. Then again this y of n, right? Y of n is equal to omega n plus this omega n is added with y of n minus 1 is multiplied with the a1, right? Y of n minus 1 into a1, because see here, see this equation, right? So I need this one, right? So I need this one. These terms is added with omega n, right? Wn, right? Plus wn, right? So that's why I wrote omega n plus, right? Then afterwards is added with minus a1 into y of n minus 1, right? Omega n plus is added with y of n minus 1 is multiplied with a1 coefficient. Similarly, plus y of n minus 2. I mean, here I have two delay element. This delay element is multiplied with y of n. It becomes y of n minus 2. That one is multiplied with the coefficient minus a2. Right? So, we will get this. So we are writing these equations in this structure, right? So this is second half of the equation, right? After that, what we are doing, we are combining those two structure, this one and this structure. So after that, we will get this whole structure. This is the direct form 1 realization structure. Just we are adding, I am combining both the structure. That's all. Nothing that, right? This is very, very easy, right? See here, this is a first structure, right? This is the first structure, right? So first half of the structure. This is the second half of the structure. Just I am combining these two structure. So finally I will get direct form 1 realization structure for the given equation. That's all. So you will see the problem related to this, right? Hope you will understand this one. Thank you very much.